So, have you been in this situation in which you solve this geometry problem and get an answer? You think you have done everything correctly, but your answer is simply not there in the answer choices. Then you scratch your head and look at your solution 3 more times just to find out what you did wrong. And it turns out that you did nothing wrong. It's just that the correct answer in the answer choices is expressed in a different way than your answer. And the process of going from this type of number to this type of number is called rationalizing the denominator. Now, what the heck is rationalization anyway? And why the heck should we even rationalize the denominators? Rationalization is converting an irrational number such as root 3 to a rational number like 3 by multiplying the irrational number by itself. And I'll give you some more context and a few more examples later in the video. By the way, this idea has been explained really well by Kumar from this Harold and Kumar movie through a really beautiful song. And if you wait a minute, I think it was a poem, not a song. Anyway, if you want to check out this interesting rendition, you can search for root of 3 Harold and Kumar. But if you decide to watch this movie, I would check my ID first because it's rated R. Most of my viewers are supposed to be at least 23 anyway. I personally thought the poem was really cool. Okay, we got distracted a little bit here. Back to rationalization. Why is it called rationalization though? In this case, irrational does not really mean illogical or unreasonable or anything like that. It actually has nothing to do with that and everything to do with the word ratio. If you remember, rational numbers are those that can be expressed as a ratio of integers. And you can easily go from an irrational denominator to a rational one by multiplying the numerator and the denominator of the fraction by the original denominator. That gives you root 3 over 3, clearly a rational number. Now, why should we rationalize the denominators? Back in the pre-calculator era, people either had to do the mental math or manual calculations. There was no other way. Now, I think everyone can agree that it's much easier to get a numeric equivalent of square root of 3 and divide it by 3 than divide 1 by the square root of 3. As you can see here, dividing 1 by the square root of 3 requires an intensive long division process, and if you're interested, you can pause the video and try to make sense of this. In summary, multiplication by an irrational number is a lot better than division, especially if you have to do them manually. And trust me, it will get a lot worse when there are larger numbers such as 10 over the square root of 5 versus 10 root 5 over 5. And if someone needs to hear this, I multiplied the numerator and the denominator by the square root of 5. I expect all of you to understand it by now. This will be equivalent to a 2 root 5, which will obviously be a lot easier to convert into a numeric approximation than this. Now let's go back to the geometry problem that we started with. Remember, our answer was 36 over root 3, and at this point, I'm pretty sure we all know what to do. Multiply the numerator and the denominator by the square root of 3. That gives you 36 root 3 over 3, or simply 12 root 3. Finally, I do want to mention that those of you who are taking the GRE have an option to get a numeric equivalent of your answer on the given on-screen calculator and check which of the 5 answers will be equivalent to your answer. But this process can be quite tedious because you may have to check a few times before you finally get your answer. Of course, it's a lot better than being completely clueless after this step. And those of you who are taking the GMAT, unless you have super mental math abilities, you will be stuck with rationalization, because remember, you're not allowed to use a calculator in the quant section. And if you want to practice rationalizing the denominator, what about 7 over square root of 7 and 30 divided by square root of 5? Let me know your answers in the comments. And as always, thank you for watching.